Lab 1 report on constant velocity motion. In this lab, I observed the motion of a real object, analyzed its position with tracker, created a computational model, and then compared my model with the experimental data. For this experiment, I recorded the motion of a expo marker rolling across the table. I made sure that the motion was one-dimensional and captured the object moving across the screen without moving the camera. I also placed a calibration stick in the video so tracker could measure the distances accurately. Next, I analyzed the video in tracker. This gave me position values at different times. As you can see in the table, the X position increases nearly linearly with time, which is what we expect for constant velocity motion. The Y values also stay close to zero, confirming the object is not accelerating vertically. Here is my position versus time graph from my tracker data. The points fall almost on a straight line, which shows that the object's velocity is constant. The slope of this line gives the velocity. I then created a computational model using GlowScript. I set the initial position to 0.017 meters and the initial velocity to 0.731 meters per second. Since the net force is zero for constant velocity, the velocity remains unchanged throughout the motion. The program updated the ball's position each time step and plotted the position of velocity versus time. And here you can see the code that I used and also the graph that was outputted afterwards. Okay, my model versus observations. When I compared the experimental data with my computational model, the two matched pretty closely. Both show a straight line increase in position over time. This agreement confirms that my assumption of the zero net force was correct for the object's motion. It was just slightly lower for the actual observed and I believe that's because, over time, the object slowed down. And so why the mismatch? One question is, why the mismatch? It's because, initial error in the 10 to the negative 2 syntax and the tracker calibration could be it. But I really think it's probably, like here you can see, at the very beginning there's a large interval that it jumps, but at the very end time it changes much less dramatically. So I believe just the object slowed down as the video went on. Okay, to fix this I could set v of x equal to the measured slope, about 0.5 to 0.6 meters, because when I initially got the data I just did the first interval, from 0 seconds to 0.019 seconds. So if I did the entire interval, then it would probably match a lot more closely, and the number would be a lot lower than 0.731, which is what I had. It'd be around 0.5 to 0.6. Okay. One question is, what if I flipped the axis in the tracker so that the position x became negative? In that case, the slope of my position versus time graph would be negative, but the speed and overall conclusions would stay the same. Another question is, what does it mean physically that net force is zero? It means that all the forces acting on the object balance out. For example, there could be pushes and pulls, but they cancel so that the object continues moving at a constant velocity. So, to summarize, I observed the motion of an object moving at constant velocity. Tracker analysis showed a straight line position versus time graph. My computational model with zero net force accurately predicted the data, and the comparison confirms that Newton's first law holds. With zero net force, objects move at a constant velocity. Thank you for watching.